Okay, we're going to write a function that will add two singly linked lists together. So we'll put the numbers in the singly linked list. So say we had 3, 4, and 5, and our other list was 6 and 7. We're going to actually add them this way: 543 plus 76. So that would be 9. So it's 619. And then we would want to return a linked list in the same format. So 9, 1, and 6. All right, so to do this, we're going to actually just walk through each list and take advantage of the fact that they are linked kind of backwards and in reverse order, because when you're adding things, you're always adding kind of the 1s, then the 10s, and so on and so forth. So we can start by looking at the first elements in the lists and adding those together to get our 9, then moving on to the second lists, adding those together, and then we would have to take care of carryover values, like when we're adding 4 and 7, we have that, so we would end up having that extra carryover 1, and then there's nothing left in the second list, and we would add on 5 plus the 1 to get 6. All right, so let's go ahead and get started. Say we're going to make a linked list class, and we could put this function right inside of that class. So we have a linked list, and in that it has a head, and then we have a node class that we can just define inside of our linked list for these purposes. It's got data in it, and those are ints. It's got a next node, and if we initialize that, it would be taking in the data, and then data equals D, next equals null. Okay, and then we can create our method. I'm going to go ahead and start it up here. So it returns a node, which is going to be the head of the new list. And it takes in two nodes. Okay, and so we're going to make some kind of temp nodes and a real one. So we'll make a result node that'll start our list, the new list of results. We need a previous. And we'll need kind of a temp or a buffer node. Okay, and then we also have to keep track of our carryover values and our sum. Okay, so while first does not equal 0, or null, I should say, equal null, and second does not equal null, then we've got, we want to calculate sum, and that is going to equal our carryover value plus, as long as there's something in the first, so you can use a ternary to get that going. So if first does not equal null, then we want to do the data in first, otherwise 0. And then we can do the same for the second. So as long as it doesn't equal null, we'll add that second data in, otherwise 0. So that's our sum. And then we have to figure out if there's any carryover value. So carry would be if sum is greater than 9, then we want carry to equal 1, otherwise 0. And then let's do this. And then we'll do we have to recalculate sum because the amount we want to only put in there is that kind of remainder. So we're going to mod it by 10. To get that that amount. And then we're going to make our new node, and we're going to send in sum. And then if it's the first node in our list and we're making our result list be our main list that we're going to return. So if it's the first time, then we're going to want result to equal the temp so that we can keep track of the head of our new list. And then otherwise, we just set previous.next equal to temp and previous equals temp. We want to make sure that we check if first.next, or actually we can just check if first does not equal null, then we want to do advanced first.next. I should say first equals first.next. If second does not equal null, then second equals second.next. And then that is going to be the end of our while loop. So we can close that off. And then we want to do one final test to make sure we don't have a carryover, because if it has any value still in it that we didn't place into, that we didn't use within a sum or something, we want to use that up. So if carry is greater than 0, then temp.next is going to equal new node and for the carry. Then when all is said and done, we return the result. Okay, and then that's the end of that function. So now we can kind of step through it real quick and make sure that it's going to work the way we think it is. So we can try it with our example here, and we can set this is second, first. So if we go in and node result equals null, previous equals null, temp equals null, carry is 0, we'll keep track of carry, and we'll keep track of sum. Okay. While first does not equal null and second does not equal null, and that is true for both, sum equals carry, which is 0, plus first data, which is 3, plus second data, because that is also not null, which is 6, so that's 9. Carry is equals 0 because 9 is not greater than 9, so carry is 0. And sum equals sum mod 10, which is still 9. So temp equals new node sum. So here we have a new node with sum in it. It's going to have this being null, and this is temp. If result equals null, which it still does, then result equals temp. And we skip over the else, then previous equals temp. So this is also previous. All right, if first does not equal null, first equals first dot next. So first is now pointing to this 4. We'll just make it a different color arrow so we can see it. And second does not equal null, so it is now pointing here. Okay. Okay. And then we go around if first does not equal null and second does not equal null, and both those conditions are true. I'm going to point that to null, so we've got that there. So sum equals carry plus, so carry is 0, plus if first is not null, we want that, so first is 4, and then second is not null, so 4 plus 7, and that equals 11. Carry equals, if sum is greater than 9, it's going to be 1, which sum is greater than 9, so carry is now 1. Sum is going to now become 11 mod 10, which is 1. And we skip over if result equals null, else previous dot next equals temp. Oh, I forgot to I skipped a line. So temp equals new node. So we go with a new node, and we're going to be calling it temp. And it's going to contain sum, which is 1. So then we say previous dot next equals temp. So previous is here. So its dot next is going to equal temp. If first does not equal null, which it does not, first equals first dot next. So now first is here. And if second does not equal null, then second equals second dot next. So second is now pointing at this null. And we go around, while first does not equal null, that condition is true. So we can go into our while loop. And sum equals carry plus. So carry is 1. So 1 plus. If first is not null, then we go in and 1 plus 5. Second is null, so we just add a 0. So that equals 6. Carry equals sum is greater than 9, 1, otherwise 0, and so it's going to be 0. Sum equals sum mod 10, so sum stays 6. Temp equals new node with the 6 in it, and this becomes temp. And result is not null, else prev.next equals temp. So here's our prev. And actually, we forgot to increase that, but it did happen. So here's prev, and its dot next equals temp. If first does not equal null, we advance it. So first is now pointing at this null. Second already equals null, so we don't do anything. We go up into our while loop. If first does not equal null, well, that's false. And second does not equal null, that's also false. So we get out of our while loop. If carry is greater than 0, which it's not, so we don't do that. And then we return result. So we would be returning results, and the answer is 619. And let's see if that makes sense. So if we have 345 and we're adding on, oops, we're doing that backwards. If we have 543 and we're adding on 76, 6 plus 3 is 9, 4 plus 7 is 11, carry the 1, we get 619. So that is the correct answer. And this is done in O of n time, because we have to travel and visit each element one time, and no extra space. Well, other than creating the new list. So it's kind of a constant extra space.